Thanks everyone for coming, and thanks to Filex for the opportunity to present here today. I'd just like to start with introducing Paul Mason, who is another doctor who will come up for question time at the end, but he and I have very much been involved with this the whole way through. As you've heard, my name is Doron Sher. I'm an orthopedic surgeon. My specialties are knee and shoulder surgery. And you've got to ask, why would an orthopedic surgeon be here talking to you about nutrition? And the answer is that a lot of my young patients have arthritis and they're overweight. And you look at a knee, 3 times your body weight goes through your knee when you take a step, and 6 times your body weight goes through your knee when you go up and down stairs. So if you want to get less knee pain, you need to lose weight. But the current exercise paradigm is you need to exercise to lose weight. These people have sore knees, they can't exercise, there's no way for them to lose weight. Now, I love exercise, it has lots of great benefits. Weight loss just isn't one of them. So a lot of these people have seen dietitians, they've been to Jenny Craig, Weight Watchers, all these sorts of things. A lot of them have had gastric banding, but then over about a 5-year period, they've put the weight back on again because they haven't really changed what they eat. So I was looking for a way to avoid total knee replacement for these patients who are relatively young, and I wanted a diet that was anti-inflammatory for them as well. Now, these guys are probably going to need an operation at some stage anyway, but the thing is, if we can do it later, then it's going to last longer and they're going to have less time off work. Also, the later we do it, the less income loss that they have, which is important for them. So my wife is an exercise physiologist and Pilates practitioner, and she's actually presenting 2 doors down and was very upset that we got the same time slot. That's why I was very happy to see that it was being recorded so she gets to see the lecture as well. She's been talking to me about healthy fats for a long time, but I was never really satisfied with the science of whether fat was okay or not. And so I didn't get really on board with her. But it was about that time that Paul Mason and I crossed paths. And Paul had personal success with this, as well as being a sports medicine physician, treating athletes and getting excellent success rates with them. So Paul gave me a reading list. I went and read all the books that he suggested that I do. I then got out a whole bunch of textbooks and listened to lectures where I could and went to meetings where I could to learn about this and really get myself up to speed on the science of low-carb, moderate protein, high-fat diets. So before we opened the clinic, I wanted to make sure it was completely safe and also effective. So I did what any good doctor does. I tried it out on my family. All right? Now, I love my family. My brother lost 35 kilograms in just over 6 months just by changing his diet, not by changing his exercise. My mother in her 70s, who was on the borderline of needing diabetic medication, is now not needing it at all. My dad, who was a bit overweight, is now back to a healthy weight as well. I mean, even my kids are low carb, they just don't realize it. So once I was satisfied that it was safe and effective, we opened up these clinics, and the results have been absolutely fantastic in what is traditionally a very tough weight loss group. And today I want to take you through the science of this journey that I've been through, and it is quite a scientifically oriented talk. So it may seem that I'm leaving some topics uncovered, but I will come back to them. And if you do have questions, please write them down, because at the end I've left a big chunk of time that we can do a Q&A session with Paul and myself together. I'm not talking about optimizing athletic performance today because that's a completely different subtopic, but again, we'll be around afterwards if any of you want to come and talk to us about that. So the first thing to understand is, what is food? Food is where we get our energy. So protein, fat, carbohydrates, minerals, vitamins, and a few other things. Glucose is able to be synthesized in our body. So we don't need to eat glucose to have glucose. And in fact, there are no diseases where you are carbohydrate deficient. There are diseases where you can be protein deficient or fat deficient, but there is nothing that will make you carbohydrate deficient. But on the other hand, there are plenty of diseases where you have carbohydrate excess, such as diabetes. So we'll come back to this slide a few times, because the hormone that acts at a cellular level of what we process is insulin. And what I'd like you to notice over here is this is time in minutes, and that's the insulin spike, and that's when you eat. So you eat the food, you get a massive spike of insulin with carbohydrates, about half of that with protein, and a much, much lower spike with fat, which returns to normal far more quickly. Now, in a healthy person, insulin is very important because what it does is builds muscle. It drives your amino acids and your glucose into the muscle to help build muscle, so it's absolutely fantastic. But why is it important that so much of our population is metabolically unwell? Because in those people, insulin has a completely different effect. It doesn't build muscle for them. What it does is stores fat. So food is a combination of all of these three things, and it would make sense that we eat foods that don't give us this big insulin spike if we can help it. So at any given moment, we have about 5 grams of blood sugar in our bloodstream. That's for a 70-kilogram male, less for females, less for kids. So if we eat sugar or other carbohydrate-containing foods, they're absorbed via the gut and they get into the blood sugar rises. So all carbohydrates, regardless of what they start off as, end up as glucose in your blood. Now, the body intuitively knows that glucose is very damaging, and I'll go through why in just a minute. And so in the body, these alarm bells start ringing. Wow, there's glucose in the blood. Let's get it out of the blood. What does it do? It pushes the insulin up to drive the glucose out of the blood so that you're safe. So now we're going to talk about why glucose is damaging to the body. If you combine protein and sugar, the protein binds to the sugar and it denatures the protein. And that protein is very important for your body. So as we cross-link them, we take away their normal function and damage them. So if you have uncontrolled diabetes, your blood sugar's high, every one of your cells is bathed in the soup of glucose, which leads to oxidative stress and inflammation, and that's where you get these AGEs, or advanced glycated end products. Now, the damage that's caused by the glucose is not reversible, and until that tissue is replaced, it will stay there. So cross-linking inactivates the proteins, and whether we like it or not, this is taking place in our bodies all of the time. If we have a low blood sugar level, it happens less. If we have a high blood sugar level, it happens more. How can we measure this? Well, one of the tissues that's in the blood are our red blood cells. So that's a protein, and the sugar can bind to the red blood cell. And there's a blood test called an HbA1c where we measure the last few months' worth of blood sugar by doing this test. And that's usually used in diabetics to monitor how good their blood sugar has been. Now, these AGEs slowly build up in the tissue, but eventually the damage becomes obvious. So these are the tissues that are most vulnerable to glycation because none of them require insulin to get glucose into them. They can all absorb glucose very easily. So what happens is that you can get glaucoma in the eye, you can get high blood pressure, you can get joint aches and pains, you can get things like dementia, you can get problems with your pancreas and your kidneys leading to blood pressure and diabetes. So if you think of us as low temperature ovens, 37 degrees, we're cooking ourselves in our glucose over a 70-year period. So we're going to get these things, but we'll accelerate them if we've got more glucose in our blood. So what are the possible outcomes? Well, what are the main diseases that we're worried about in society right now? Dementia, Alzheimer's, things like macular degeneration, cancer, psoriasis. All of these things are most likely potentiated and accelerated by these AGEs. What about low-density lipoprotein? Has everyone heard of low-density lipoprotein? Okay, so it's one of the fats, and we'll talk about it a little bit more a bit later. You just need to accept right now, not all LDLs are bad. There are some good LDLs as well. But glycation is proportional to the glucose concentration. So the higher the blood sugar, the more glycation, and that's what happens to the LDL, is that the LDL can become glycated LDL instead of good LDL, and this is very harmful for us because this increases the damage to the lining of the blood vessels. Now, there's a difference between glycosylation and glycation. Glycosylation requires ATP. It's a controlled energy releasing step which the body uses to create healthy proteins, etc. Glycation doesn't require the use of any energy. You don't burn an ATP or an NAD to glycate something. The sugar just binds to it and damages it. So it's a great question. Glycosylation and glycation are not the same thing.